Let's look at a simple series circuit. I have a 10 volt power supply, a 470 ohm resistor, 150 ohm, and a 270 ohm resistor. Notice my voltage source is reversed. All that means is my current direction is this way. Now this is a series circuit. There's one path for current. So let's do some simple calculations. The total resistance is the sum of the resistors. In this case it's 470 plus 150 plus 270. So for my total resistance I have a total of 890 ohms. If I wanted to calculate my current, my total current is total voltage divided by total resistance. So I divide that by 10 and I get 0.01123, 0.01123 amps, or converting to milliamps, I move the decimal place over 3. That gives me 11.23 milliamps. So I have 11.23 milliamps in this circuit. To calculate voltage drop across resistor 1, I would take that current and multiply it by the 470 ohms, which gives me 5.28 volts. Voltage 2 is going to be that current times 150 ohms, which will give me 1.68 volts. Notice the smaller the resistor, the less voltage. And finally, voltage 3, again, it's the same current. That's 1123 milliamps times 270, and that equals 3.033 volts. Now if I add the voltages up, if I take the 5.28 and I add the 1.68 and I add the 3.033, I get 10 volts. Close enough. It depends how you round off. This came out to 9.933 volts. So that's all the calculations. Let's take a look at another circuit. How about this one? Here I have 18 volts, 5.6K, 10K, 6.8K. Current is around this loop, so it's a series circuit. My total resistance then is 5.6K plus 10K plus 6.8K, or 5,600 plus 10,000 plus 6,800 will give me 22,400, or 22.4 kilo ohms. Now instead of finding current and using Ohm's law, we can also use voltage dividers to find voltage drop. So let's do this problem that way. V1 is a ratio of resistor 1 voltage with the total resistance, resistor 1 resistor with the total resistance times 18 volts. So I take 5,600, I divide that by 22,400, multiply that by 18, gets 4.5 volts. So V1 is 4.5 volts. V2 is going to be 10K over the total resistance times 18 volts. So that would be 10K divided by 22.4K times the 18 gives me 8.03 volts. Now for V3 I can use voltage dividers again, or Kirchhoff's voltage law. I can also say it's 18 volts minus 4.5 minus 8.03. So for V3, I can say, if I subtract those from 18, it's going to be 5.46 volts. So let's verify that. with voltage dividers? Well, voltage divider formula again is that resistor over total resistance times 18 volts. So V3 is going to be 6,800 divided by 22,400 times 18, and that comes out to 5.46. 5.46 volts. So I didn't even need current on this one to do all of these calculations. Here's another one. This one says we're measuring 6.2 volts. Is that correct? Or maybe more than likely what the question is, now that I notice there's no voltage source. So the question is, what is the value of the voltage source? Well, because this is a series circuit and this is just a meter connects directly across a resistor when you're measuring voltage. All I need to do is find each voltage drop, add them up, and I'll get source. Well, you may look and say, well, how am I going to find these voltage drops when I don't even know source? Well, we can work backwards. What I know is Ohm's law. Ohm's law relates three quantities, voltage, current, and resistance. So mathematically speaking, if you know any two of these quantities, you can solve and get the third quantity. Here I know voltage drop and I know resistor 3. So what I can do is find current. Now because then I have to use my knowledge of a series circuit once I have current. By knowing this is a series circuit and finding current 3, I've also found the total current in the circuit. So let's say that I3 is going to equal voltage 3 over resistor 3. So it's 6.52 volts divided by 82 kiloohms. So 6.52 divided by 82 kiloohms comes out to 7.95 microamps. 7.95 microamps, or it comes out to 1, 2, 3, 4 zeros, 795. So if I move it over 6 places, 1, 2, 3, 4, 5, 6, 79.5 micro. 1, 2, 3, 4, 79.5 micro. Let me just fix that. 79.5 microamps. Alright, that is the total circuit current. So now I can take that and find V2. V2 is 79.5 microamps times 120K. So V2 comes out to 9.54 volts. And V3, we already did V3, this is V1. And V1 is equal to 79.5 microamps times 100 kiloohms. So V1 is equal to, so I take the 79.5, multiply that by 100K, 7.95 volts. So therefore, my source voltage, by knowing Kirchhoff's voltage law, is going to be 7.95 plus 9.54 plus 6.52. So it's 7.95 plus 9.54 plus 6.52 is 24.01. So I would say that this is equal to 24 volts. Okay, here we have a 15 volt source, 680, 1K, and 470. So what I want you to find on this one is calculate the total current and calculate the voltage drop across each resistor, and also calculate the power dissipated by each resistor. So first step, series circuit, total resistance. So I take 680 plus 1,000 plus 470, which gives me 2150 or 2.15K. Total current is going to be 15 volts over 2150, which is 6.97 milliamps. Alright, then V1, I'm going to use Ohm's law to find all of the voltage drops because it's easier once I know current. I guess it doesn't matter, but so 6.97 times 680 is 4.74. So V2 is 6.97 milliamps times 1K, which is 6.97 volts, and V3 is 6.97 milliamps times 470, which is 3.28. And again, I want to just make sure that that is 15. Check any math mistake. So this is 7 plus approximately 5, which is 12, plus approximately 3. So that's about right, 15. Okay, so now P1 is voltage 1 times current 1. So it's 4.74 volts. And again, current is the same, times 6.97 milliamps. So 4.74, which is 33.06 watts, milliwatts. Power 2 is V2 times I2, which is 6.97 volts times 6.97 milliamps. So P2 is equal to 48.62 milliwatts. And finally, P3 is voltage 3 times current 3, and it's 3.28. And again, current 3 is still total because it's a series circuit. So it's 6.97 milli times 3.28, which gives me 22.88 for P3. 2288 milliwatts. Last problem. This problem states calculate resistor 2. What is the value of resistor 2? So again, we have to work backwards and figure out what we know with what's given, and use Ohm's law to find the other quantities. So here it says I have 100 milliamps of current, I have a 12 volt source, and I have a 100 ohm resistor. One way I can do it is knowing that total resistance is total voltage divided by total current, I have both those quantities. So I can say it's 12 volts divided by 100 milliamps, which would give me 120 ohms for total resistance. And knowing that RT is R1 plus R2, R2 would have to be 20 ohms. Alright, so let's say we didn't see that. Another way we could find it is we could say there's 100 milliamps through resistor 1 and resistor 2 because it's a series circuit. You can therefore find voltage drop across resistor 1. Voltage drop across resistor 1 is 100 milliamps times 100 ohms, which comes out to 10 volts. That means voltage 2, there has to be a 2 volt drop across there because 10 plus whatever this is has to equal 12. So if there's 2 volts here, the next thing I can do, I can say, well, I know 100 milliamps is over here, so I can say that resistor 2 is going to be 2 volts over 100 milliamps or 20 ohms. That's just another way of solving that problem.